Very good evening. Me and my group will present about the water level control. Let me introduce my members group. Okay, me is Muhammad Arif Ali bin Muhammad Fuadi.
My name is Ahmad Syahid bin Idrat. Committee number is 173523.
My name is Muhammad Ali bin Osri bin Committee number 173591. And next,
My name is Nurhazwani bin Rahman. My entry number is 174713.
And me, Hamiska David Rais, booking number 172953. And last, my name is Muhammad Shafiq Aizat bin Farah Samuddin, booking number 171994.
okay, that's all my members. Okay, let me proceed with the second slide. Okay, I will discuss about the introduction and application. Okay, the introduction of the closed loop system is one of the element in which the heating element inside the system. So the control system can cause the error and will send the feedback to the input part and control in within the desired range. Besides, the system is called closed loop, and it is because of the input to the output, and it will send the feedback to the input, and this relation will look like a loop, cycling. And the component that involved in this closed loop system is controller, actuator, plant system, and sensor. Okay, this water level control application in industry widely used in a chemical plant and power plant. This closed loop system in form of water level control can reduce the risk. Okay, this is the block diagram of closed loop system. The first is input through into the controller and go to the actuator and then to the plant. When there is a error, it will sense by the sensor and will give a feedback back to the input. Okay, I will proceed with the Alif.
Okay, Assalamualaikum and a very good evening to my group member and to all here. So I will presenting on the device named as actuator. So as we all know, basically actuator, the device named as actuator is contained inside many of the closed control loop system. So what is actually mean by actuator and what is the function? So based on the first slide, okay, so the function is actually the device is used as to convert the electrical output to cause a motion, which means the electrical stand for the graph generation, the generate of the curve of the graph from the electrical output, and then it will cause a motion such like pneumatic, which means if from the graph it can cause a motion such as to take a robot arm to take something. Okay, and then after that, in these industries, the actuators have so many types. So here, as you can see in front here, we have five of them, which means the first one is hydraulic actuator, second mechanical, pneumatic, thermal, and electrical. So among these five types of actuator is actually widely used in industries. So what is the benefits of the actuators? So the benefits of the actuator is actually it can be act as an agent, or in another word is it can be remotely controlled, not so far the range, and then it can act as an agent to shut down the system immediately if there is emergency situation, which means human cannot touch the machine, but it can act as an agent to stop the system immediately. So next, I will proceed on transfer function of an actuator. So this is basically the transfer function. Gs equals to 1 over ts. So here the question is write down the closed loop transfer function. So ts is equals to 1 over gs plus 1, and here is the answer, 1 over ts plus 1. So here is my reference that I refer to do my part, which is actuators, and next the presentation will be proceed with Amir Iskandar, which is plant system of water level control. Thank you.
Yes, Assalamualaikum and very good evening to all my fellow friends. So my name is Amir Iskandar and my part is water system of water level control. As we know, there is a lot of plant system of water level control that we can apply, but for our group we choose water level control for our main resources. So for the example of the plant for these resources is rectifier and filter. So let me explain about what is rectifier and filter first. So the rectifier is an electrical device that converts alternative current to predictably reverse direction to direct current, which flow in only one direction. And this is also known as rectification. And this rectifier have many uses, but they are often used in solving a components to the DC power supply and high voltage current power transmission system. Rectification may serve in roles other than to generate direct current for use as source of power. This is same as what we call the programming language. For us to understand, we will convert it into programming that machine will understand it. So this is for rectifier and filter. There is an example for, as you can see in front of you, there is a diagram, and that process the process of the rectifier and filter. So the full wave rectifier have fundamental advantage over their half wave rectifier counters, and the average of DC output voltage is higher than for the half wave, and the output of the full wave rectifier has much less ripple than of the half wave rectifier, producing a smoother output waveform. So what we call the easy to understand is from the graph you can see there is a transformer, and go to the rectifier bridge where this wavelength processes to just for one side of the part, yeah, and then go to the filter, whereas the shape will become slightly constant, and lastly we will go to the regulator where the graph will be smooth, easy for us to understand. And also in a full wave rectifier circle, 2 diodes are used and one for each half of the circle. Yeah, for this water level control we will use 2 diodes, and this configuration result in each diode quantity in turn when its anode terminal is positive with respect to the transformer center point C, producing an output during both half circle twice that for the half wave rectifier, so it is 100% efficient as shown. So for the transfer function that I get for this plant system is through this circuit wherein the plant system. So yeah, we will use a V output and V input so that the transfer function will be end like this. So for the next one is control system. We will be continued by my friend Nur Hazwani.
Okay, so I will proceed to the controller system. Okay, this diagram show where the controller element the location. Okay, so we can see it between the set point and plant. Okay, so that this graph show the PID controller of the closed loop, where we can see the amplitude of this graph. Firstly, it will increase, and after that decrease, increase, and finally it become constant. Okay, what is PID controller? Okay, PID controller, the controller basically its function is to control the water's level in the tank. And what we can see is in many industry, if we want to get our water level, there is some reduction. That means there is some reduction. We cannot maintain our water level. Okay, for example, if we have a plant, that plant can produce the wastewater, but the water treatment plant can work with the best way by make a constant flow. So what we want is we need to use the proportional with the low gain. Okay, the gain can be set to open the discharge valve before the tank full, because we need to close it before the tank empty. Okay, if there is a suddenly increase in the flow, we need to the level will increase and the flow from the tank also will increase. Okay, after that, the transfer function of controller is what we can see from here. There is the derivative time constant, and also if there is no derivative action, we only have PI controller. Okay, the effect of PID controller is for proportional controller, it can show the effect of reducing race time, and it will raise but never stop the steady state error. For the integral control, it will eliminate the error, but it will make cause the response become worse. And finally, derivative control will increase the stability of the system, but it will reduce the overshoot and increase the response. Okay, this is what I say. Then okay, this is my reference. So we proceed to Shahid.
Right. Attention gentlemen, now we proceed to the most important part, and not the most important part of our system, which is a feedback system, which means sensor. Right. As an introduction, sensor is a device that receives a stimulus and responds with an electrical signal. Alright. For the water level controller, the sensor is being used is the direct sensor. Usually, sensor nowadays used with transducer, which means the transducer is something need to convert the signal from sensor into the another element, just like a microphone. They convert from wave sound to the electrical signal. Right. Next, sensor inside a water tank usually being used to control the level of the water inside the tank with our desired level. Right. For the working principle, this is the working principle of the sensor. Right. As you can see, the floating element will rise up along with the fluid, which means when the fluid is increased, the float will rise up, and the sensor will detect the displacement of the fluid that increase. Then it will be transferred into the electrical signal into the monitor. Right. For the basic transfer function is, as we see, this is the feedback path, which is the signal element. Then if the gain part, the power part, if we set into something like 10 meters of water tank, then if the output of the input of the water inside the tank has reached into 10 meters, then the sensor will send a electrical signal to the motor to shut off the motor. Right, the sensor acts as a feedback signal, as I said just now. Then the output from the system is equal to the output of G times the error. So note that the error signal is theta E is also the input of the feedback from block G. This is the description from the basic block diagram that Alif just said in the beginning. Alright, this is the output that from the block diagram that I just shown. Alright, this is just the reference that I made for the sensor. Thank you. I would like to proceed to Muhammad Shafiq.
Hello. So for my part, I will be presenting about the working principle of water level. So basically, we just wind up to the beginning of the slide. So the principle is simple. For the water level, we use closed loop control. So basically, closed loop control, we see this diagram. We can see the sensor. So the most important part in the control system, control loop control, closed loop control is the sensor. It differs with the open loop control. It doesn't have any sensor. So it also involves feedback control. You can see when there is some error, we will go back and the sensor will preset the value to the set point. Then we correct the value to the controller. So this is one of the example of water level control. You can see this is a simple diagram of a system that involves water level control. We use the feedback mechanism, closed loop control. See the speed, tank, then level control bar, the set point, like that. Then level measurement. The level measurement is not good. We go back, then we reset it. Simple. Okay, now proceed with it.
Okay, lastly, as a conclusion, this water level system basically widely used in industry. Normally, it used in shipping and construction. Besides, from this presentation, we all can learn about this system deeply and the way system work properly. And furthermore, we can able to apply it when we working in the future. Okay, that's all from our group. And Assalamualaikum and thank you.
Thank you.
Bye.